we talked about the triangle, right? Both of these we already talked about. Is that correct or not? I can't remember where we left off at. Okay. Have we done those two yet?
Yeah, we did both.
Okay. So down here, select or identify the polygon with no lines of symmetry. It should be easy to identify because the one that has no lines of symmetry is the one that looks oblong, okay, or off center. And this one has some symmetry to it, right? If I draw a line right down the middle, it has symmetry. Same thing here. I can flip it over on top of each other. Okay, this is a regular hexagon. I have all kinds of different lines of symmetry here. This is the one that's kind of a weird looking figure, right? If it's a weird looking oblong, kind of irregular shaped figure, that's going to be the one that has no lines of symmetry to it. Okay, so the one that has no lines of symmetry would be this guy right here. All right, we only got one page of notes left. Here we're talking about what we call the reflection postulate. A reflection is a rigid motion. Anybody remember what we talked about with rigid motion from day one? I know it's been a few days. Or back to, it was actually on translations we talked about rigid motion. What does it mean to have rigid motion? Go back and look at your first day's notes from 4-1. See if you can find it. Find it? What's it say, Xander?
It's a transformation that preserves length and angle measure. Another name for rigid motion is symmetry. Rigid motion maps lines to lines, rays to rays, segments to segments.
Okay. So essentially, rigid motion means those figures will have the same size and shape. Everything about them will be the same. Their angle measure is the same. Their length is the same. Everything about those two figures will remain the same. The only thing different is it's just in a little different location. On the first lesson in 4.1, we talked about taking a triangle or some kind of figure and mapping it left, right, up, down, whatever. With reflections, if I just simply take a figure and reflect it over a line, did I change the size and shape of that figure? No, okay? Everything about that figure will remain the same. Later on in the chapter, we'll talk about some different transformations that will change the size and shape of our figure. But as of right now, we haven't seen that. So everything should remain the same size and same shape of what we started with. Okay, so the last page here is going to talk about a new type of change. Okay, all of these are changes. Transformation means to change. We're going to change the figure in some shape or form. So far we did a translation, and I told you the name for that was a slide, right? We're just going to slide it left, right, up, or down. That's the word I use a lot of times is a slide. For a reflection, a lot of times I will use the word flip, okay? Because that's essentially what's happening is we're just flipping it over a line. It's going to sit in a different direction. We're going to combine those two together and make what we call a glide reflection. So a glide reflection is where we're going to kind of slide it over in some direction, could be multiple directions, and then that will be followed by a reflection, okay? So it's a translation followed by a reflection. So the translation will happen first. And then we're going to take that new figure and we're going to flip it. So we got multiple transformations that are happening. At the end of the first section when we did that, we took a figure and we moved it somewhere, right? And we got a new figure. And then we took that new figure and we slid it again in some direction. So that was just a multiple translation. This one's a translation with a reflection. So we got multiple things that are happening. All right, so here's what we're going to do. First thing is we're going to plot this triangle, okay? ABC. So we got 3, 2. Six, 3. Seven, 1. It's a triangle, so we're going to connect all those points together, and we got triangle ABC. Okay, we're going to translate it, which is what we call a slide. Okay, what does x minus 12 tell me? Left 12, okay? So x minus 12 tells me left 12. Okay, if there's no number connected with the y right here, then how far are we going to move it up or down? Don't overthink it. If there's no number connected to it, then how far up and down are we going to move it? Not at all, right? A lot of times we'll move it left 12 and then maybe we'll move it up 2 or down 2. But in this case, we're not doing anything to the y. So we're not moving it up, we're not moving it down. The only thing that's happening here is we're taking this whole figure and we're moving it left 12, okay? So let's do that. And you could subtract it from the x values or you could simply just count. So in this case, let's count. Left 12. 3 minus 9 would be, or 3 minus 12, sorry, would be negative 9. I'm going to call this point A prime. And then I'm at 6, and I subtract 12. That puts me at negative 6. And then 7, subtract 12, would put me at negative 5. Okay, and notice once again, reminder from last week, when we put that new figure up, we don't just call it A, B, and C, because it's a new figure now, so we call it A prime, B prime, C prime. Okay, that's the first. One marking means we've done one movement. Okay, but now we have a second change that's happened. So we're going to take this new figure. We're done with the original figure. We're going to take the new figure, the blue one, and we're flipping it over the x-axis. Okay, and what we talked about last week was if C, and the x-axis is this axis right here, okay? If I look at A first, how far is A away from the x-axis? Hendricks, what would you say?
2.
Okay, so how far do I need to move it?
Is it 6 or is that A?
For A, yes. Durston, you gonna help him out?
Yeah, I gotta look at it.
You guys need to pay attention. Okay, let's quit talking. Right now, A is 2 above, right? So we got to go 2 below. So I count 2 down to the x-axis. I count 2 down the opposite direction. So A double prime is what we call that one. It has 2 markings because that's our second figure. So we got our first figure, and then now this is our second change. So we call that double prime. Okay, how far is B above the x-axis? 3, right? We can count 1, 2, 3. So we're going to count 3 in the opposite direction. And that would be B double prime. Okay, and then C is 1 above. So we're going to go 1 below. We're just going to flip it over. And that would be C double prime. Hey, when I look at these 3 figures, oh, the A is off? Oh, I didn't go down 3. Thank you. That one? Is that what you're... Okay, when we look at these 3 figures, they all should look like they're the same size, right? And when I look at these three, now, this one is sitting a little bit differently. Remember, when we do a flip, this one is ABC. As I go around it clockwise, it's ABC. This one's ABC. So when I do a slide, the orientation of those letters stays the same. But now when I did flip, if I go clockwise, now it's ACB. The letters are in a little bit different order than one another, okay? But it's still the same size, it's still the same shape. Everything about this triangle would still remain the same. My angle measure would be the same. My lengths would be the same. We're not going to necessarily find those lengths or how long each side is, but just know they are the same. Okay. On this one here, same thing. It's just written out a little bit differently. Okay. They don't have the actual rule written up here like on this one here. It was written in the translation rule style like we talked about. Here it's just written out in words. So we're going to plot our figure. It's the same figure that we started with just a second ago. A, B, and C. Okay. So graph A, B, and C and its image after a translation 4 units down and a reflection in the y-axis. Okay. So this time we're only moving it down. If I wanted to do the translation, the way I would write that, bless you, xy goes to x and y minus 4. I know it doesn't ask us to write the rule out, but in some cases, some people like that better. It's better than writing it out in words like they've done up there. So whichever way you want to look at it, if you want to write it out like this, you can. You don't necessarily have to. But we're taking the whole thing and we're moving it down. So we're always doing the translation first, okay? And we're going to take all 4 points and move them down. So we're going to go 1, 2, 3, 4. So this is A prime, B prime, and C prime. Okay, and then for the reflection, we're going to reflect it in the y-axis. And what that means is over the y-axis. When it says in the y-axis, then we're reflecting it over the y-axis. So we're going to take all those points, and we're just going to start one at a time. A is 1, 2, 3 to get back here. So we're going to go 1, 2, 3 in the opposite direction. B is 6 away, so we're going to go 6 in the opposite direction. C is 7 over, so we're going to go 7 in the opposite direction. So this would be A double prime, B double prime, and C double prime. And that's our new figure. Okay, 2 changes have been applied. Okay, on the last one here, they give us the change, they give us the 2 figures. We have to identify what has happened to it, okay? So we're going to identify 2 things. We're going to identify the translation. We're going to write a rule for the translation. And then we're going to write a rule for the reflection. And we know there's both because it says a glide reflection. A glide reflection tells us 2 things have happened here. We've slid it and we've reflected it. Okay, we always do the translation first. So if I wanted to write a rule for the translation, the format that we typically will write that in is XY, meaning we're going to start with an ordered pair, whatever that XY ordered pair is, and we're going to do something to it. Okay? So this here, the arrow tells me what direction we're going. I know that I'm starting with the original. ABC is our starting point, right? And then we're going to go to prime, and then we're going to go to double prime. So the first thing we're doing is sliding it. So to get from 6 to negative 6, how far did we move? 12, okay? And so we would say x minus 12. We're taking our x value and we're subtracting 12. You can do it for all three x values, but it shouldn't be any different. They should all have the same movement, okay? If you wanted to check it, 7 minus 12 should be negative 5, which it is, okay? They should all be the same. If one of them is different, then something's wrong. Okay, what about y values? This one's 3, this one's 3, this one's 2, this one's 2. So did we do anything to the y? No, just stayed the same, right? 2 stayed at 2, 3 stayed at 3. So my y stays at y, whatever it is. We didn't move it up, we didn't move it down, it just stayed where it's at. We only moved it left 12. So that's the first movement that took place. We went 12 units left. Okay, what are we reflecting it over? Well, let's look at C, for instance. C is really easy to tell here because C prime is 1 unit above. Here's the x-axis, and we're going 1 unit below. Okay, sometimes you got to be careful because it may not always be the x-axis or the y-axis. It could be like a y equals 1 line or an x equals something line. But in this case, it is the x-axis. So we're just going to say a reflection in the x-axis. Okay.